Hello, my name is Kelvin from Educare Institute. Welcome again in our lecture session. And today we have a presentation based in Form 2 Physics. Our topic to be discussed today is moment of force. And subtopic which we should cover today is principle of moment. But before we go in deep, let's look the meaning of moment of force. When we say moment of force, is a product of the force applied and the perpendicular distance from the fixed point or pivot. Mathematically, we can express the moment of force as product of force times the distance. As we can see, moment of force is equal to force applied times the perpendicular distance. So, whereby M represent moment of force and F represent force applied, but also D represent the perpendicular distance. So, now let us do some examples on how you can calculate the moment of force. The first example states that a line of action of a force of 90 Newton acting at a perpendicular distance of 2.5 meter from a point. Then the question you are being asked to find the moment of force. So from the definition or from the concept of moment of force, we say that moment of force is equal to product of force applied times the perpendicular distance. So now let's analyze the data which we are given in the question. The first data we are being given the force applied, and the force applied is 90 Newton. But also we are given the perpendicular distance, which is equal to 2.5 meter. And our question, which we are being required, is to find the moment of force. So from the definition of the moment of force, we say that moment of force is equal to product of force times the perpendicular distance. So now let's plug our given data, then we can find the moment of force. If you plug the data, moment of force will be the force applied is equal to 90 Newton, then you will times 2.5 meter, which is perpendicular distance we are given, times the 2.5 meter. If you times, you'll get moment of force is equal to 2.5 Newton meter. So you will write that is how you can find the moment of force when you are being given some data. Now let's go to our subtopic, which is principle of moment. We know that the principle of moment, let's consider the diagram. Let's consider our diagram. This is pivot, we call it pivot. This is mass. Sometimes it can be weight, and this also is mass. But X and Y as a distance from the pivot. So according to principle of moment, it states that when a system is at equilibrium, the product of clockwise moment is equal to product of anticlockwise moment. When we say clockwise, means you go in this direction, and when we say anticlockwise, we go in this direction. So by considering this principle, we can deduce the principle of moment mathematically. We can write that mathematically we say that the product of clockwise moment is equal to the product of anticlockwise moment. So when you take y times m2, it will be equal to x times m1. So m2 times y is equal to m1 times x. That is how you can deduce mathematical principle of moment. But also we know that from sometimes you will not be given the mass, but you will be given force. So you will take force times the distance, which will be equal to either force 2 is equal to force 1 times x. So that is also the formula which you can use to find the moment of force. So now let's consider this example. A 100-gram weight is suspended (45 centimeter) from the pivot F of a light rod. If a weight W suspended 20 centimeter from the pivot balance the 100-gram weight. Then our question is to find weight W. So that is our question. We are being given a weight of 100 gram. It was suspended 45 centimeter from the pivot. Then another weight was placed 20 centimeter from the pivot. But that weight we didn't have, and we are required to find that weight. So now let's draw the diagram to show the simplification of our problem. That is simplification of our problem. This one is pivot. So now, from the principle of moment, we are required to find the weight W in order for the system to be in equilibrium. So as we learn from the principle of moment, we see that the principle of moment states that when the system is in equilibrium, the product of clockwise or the sum of clockwise moment is equal to sum of anti-clockwise moment. So when you take the sum of clockwise moment is equal to sum of anti-clockwise moment, and we see the formula, which is m2 times y is equal to m1 times x. But our m2 now it is 100 gram, but our y is 45 centimeter. But our m2 we are being given w times our x now is 20 centimeter. So that is how you can arrange your data and calculate the data which you are being required. For instance, we are required to find the weight W is equal to how much. So now you will divide by 20 centimeter both sides, divide by 20 centimeter both sides. Centimeter and centimeter will cancel out. Also 20 and 20 will cancel. So it will remain W is equal to 100 gram times centimeter and centimeter will cancel times the 45 over 20. So if you look, 0 and 0 will cancel, 2, 1, 2, 5. So it will be 5 times the 45. So let's finish our second example. So weight will be 5 times the 45. And when you take 45, you times the 5, 5, 20, 22. So weight will be 225 gram. That is the value of the weight. That is how you can find the required weight. Now let's find another example and see how we can calculate and arrive in the answer. Okay, example number 3. A uniform meter ruler is pivoted at its center. A 20 gram mass is placed at the 10 centimeter mark and a 50 gram mass at the 40 centimeter mark. Now at what mark must a second 50 gram mass be placed for the system to be in rotational balance. Now, another example, we are given the uniform meter ruler which is pivoted at the center. So let's consider the diagram on how we can simplify our question. We are being given the meter ruler and it's pivoted at the center, means from here up to here is 50, and from is also 50. That is how you can pivot the meter ruler at the center. After that, I say that a 20 mass is placed at 10 Mach centimeter. A 20 Mach is placed. So from here up to here, assume it is 20 gram, and the distance is 10 centimeter. Also, and 50 gram mass at 40 Mach. So you count from here up to, you get 40. So another mass placed 50 gram at 40 centimeter. So you are being asked that the second mass, which is 50, how long it will be placed from the center of your meter ruler. So assume you have a 50 mass